Hey guys, how's it going? So we are back with Hsrp. We're using the same topology as the first video, only this time we are going to configure some enhanced object tracking. We're going to take a look at how to achieve sub-second failover and maybe even talk about some timer considerations depending on your ISP or your specific use case for your Hsrp configuration. So let's go ahead and take a look at what we have so far. So Hsrp is running between R1 and R2. And it says here that we have preemption enabled on R1. And the standby IP is 192.168.1.1. And on R2, I believe we have preemption enabled as well. And also we've statically set the priority to 150, which should make us the active gateway. Let's go ahead and do our verification to verify that. So R2 is state is active, preemption is enabled, the active router is local. The standby router is 192.168.1.10, which is router 1. So we are going to take a look at the current failover with this basic configuration with preemption enabled, and we're going to take a look at what type of packet loss we're looking at in an event of a failover. And the way we're going to do that is by initiating some sort of link failure here on switch 5, which is the upstream switch. So here we go. So we're coming down here to the VPC. That's a part of the Hsrp topology, the logical topology. And we are going to test connectivity through our gateway. And we are getting some unreachables. So let's see if we can actually ping our gateway. Okay, looks like we can ping our gateway, but for whatever reason we're getting some unreachables on 3.3. So we're going to go up to R2, make sure connectivity is all good over there. Okay, so it doesn't look like connectivity is good. Let's make sure everything's good on our switch. So initial int EO2. Aha, so it is down. So int EO2, no shut. Okay. So since that's up, we should be able to log back into R2, guys. Now that we can ping, I bet you we can ping 3.3.3.3 after this. Maybe it might take a second for the Hsrp to come up. And we do not have any neighbors. There they are. Okay, so it's just taking a little bit longer than I expected. So let's try to ping again. We have connectivity. Awesome. Guys, I do apologize for this. I thought that interface was up. But looks like we're gonna have to open this again. And it's because we already have one open, that's why it's yelling at me. So let's try this again. So we're pinging from the VPC and we are getting replies. R2 is statically configured with a priority of 150, so we should see R2 southbound interface as the next hop for this IP, which we do. So now that we've verified that it is going through R2 to reach the end destination, we're going to send a ping and we are going to set the count to something crazy. It's like 1,000. And we are going to hit enter, and we're going to go ahead and initiate a failover event, and we're going to see how many of these pings we lose with the standard Hsrp config. So now that we have that running, the way that we're going to go about this is we're going to pull up switch 5, and we're going to make sure you guys can see this. And we're going to also ping, we're going to bring up R2. So R2 and switch 5 and then our VPC. Okay, cool. Now that we got those going. So we're going to be checking out here for loss of ping. We're going to be checking out R2 for any sort of Hsrp changes, whether it's going from active to standby. And then we're going to go in the port that's facing R2 on the upstream switch, which is interface Ethernet 02, and we are going to shut it down. And you see the timeouts, guys. 2 timeouts, 3 timeouts, 4, 5, 6, 7, 8. Looks like R2's just detected it. The neighbors have went down. Looks like we're losing a lot of packets, guys. Let's wait for the Hsrp to give us a notification that R1 is taking over. And R2 has yet to allow R1 to take over. And we are losing packets. We are losing packets. Why is this, guys? Well, I can tell you why. This is one of the downfalls of Hsrp at its static configuration. You see, the router itself, it becoming active isn't contingent upon any sort of upstream link failure. It's literally just the southbound interface. So unless we have some sort of tracking mechanism deployed to increment or decrement priority or change the active router based on other characteristics, then we are going to be losing a lot of packets, guys. So what we need to do is on R2, in the event of an upstream link failure, and vice versa on R1, we need to have some sort of mechanism configured to say that if we lose connectivity to an upstream device, that we can act on that accordingly, and we can have some sort of failover event that allows us to switch to R1 as the active gateway. Since we have preemption enabled, one easy way to do it would be to say something like this. If R2 loses connectivity to R3, we want to decrement the priority to lower than R1's current priority, which is 100. And then if we resume connectivity, we want to reinstate ourselves as the active gateway. So part of being a network engineer and getting to a point where you're comfortable with a technology is really just understanding the true business need and sort of figuring out what tools do you have at your disposal to implement this and to change the circumstance from dropping all of these packets and these being unreachables to optimizing the network and making sure failures like this, super failures like this, are not occurring, but also, after that, after we enable R1 to become active in an event of a failure, how do we optimize that? So that's what we're going to talk about a little bit in this video. And right now, I'm going to show you how to take care of this issue. So first, let's get packets flowing again by opening up this interface. And once this is up, we should start seeing some active pings come back through. There we go. So as you guys can see, we're starting to see packets flow again after the link failure on the upstream switch came back up and was resolved. Now we're starting to flow packets again. So to make sure this doesn't happen again, guys, what do we want to do? We want to make sure that if a link failure for R2, if that link from R2 to switch 5 were to fail again, that we are going to decrement its priority, and we are going to allow R1 to preempt and say, I am now the active router because you have decremented your priority. And here's how we're going to do this, guys. So all of our failure, we can basically say that if that interface was to fail again, that we would lose connectivity to 3.3.3.3, correct? So that being said, what we're going to do is we're going to set up an Ip Sla operation. And maybe I can help you guys out by depicting this a little bit better here. We're going to set up an Ip Sla operation on this guy. And for those of you that are not aware, SLA is service level agreement. But this is a feature on a Cisco router that allows us to generate traffic, sort of like probes for testing and measurement purposes. And what we're going to do is we're going to set up an Ip Sla operation on here to send an ICMP echo, just like a ping message. And we're going to set it up to send that across here to 3.3.3.3. As long as we're pinging, everything's going to be good. If we don't receive a response from this guy, though, the state of that is going to be down. And we're going to measure that state by tracking that SLA operation, and then we're going to tie that tracking to Hsrp by saying if this guy sends a ping and this guy does not reply, then we are going to decrement our priority by 51, which will make our priority 99. And since we have preemption enabled, that's going to give R1 all the confidence it needs at default priority of 100 to say, hey, you've decremented your priority because this link went down and you're 99 now. Well, I'm 100, and that means I'm the better gateway, so I'm taking over. And that's pretty much what we're going to configure, guys. So here we go. So on R2, in order to do this, we have to set up an SLA operation. So if you do a question mark, it's going to want you to do an entry number, which is just the operation number. So for this one, we'll just do Ip Sla 1, and we'll hit enter. And if you do a question mark, you see that there's all types of different traffic that you can generate. But for this operation, I said we're going to do an ICMP echo. We're just going to send a ping out there, and we're going to make sure we get a reply. So type in ICMP echo, and then the destination address that you're pinging. And we're going to source interface Ethernet 00. Ooh, that's 3. Yep. From R2. Okay. Once we're in here, we can set a bunch of different metrics like the threshold and the timeout or the frequency of the ping. But for right now, we're just going to leave it alone. Just going to leave it as at a default. Then, in order to actually make the SLA operation take effect, we have to schedule. Oh, that's the wrong one. Schedule, Ip Sla schedule, the operation number 1, and we are going to say the start time is going to be now, and the life is going to be forever. Cool. That's all you guys got to do to set up the SLA operations. Now we should be pinging, and this should be tracked. So let's do a verification command. Do show Ip Sla summary, and you can see the ID is 1, the type is ICMP echo, the destination is 3.3.3.3. It's already ran, and the return card is okay. So now, remember, we need a way for Hsrp to be able to get the results of this, right? We can go into Ethernet 01.1, that subinterface for VLAN 1, and we can type in standby and then our group number, But you notice here we see authentication, follow, IP, MAC address, name, preempt, priority, timers, and track. You notice there's no SLA, right? So the actual keyword that we have to use is track. But you see that we're supposed to set up a tracked object. We didn't do that yet, right? So we've only set up an SLA operation, but we haven't said anything to track that SLA operation. So let's get out of here and let's set up a track. So we're going to track, and we can also name it 1 just for consistency for the SLA operation. And we are going to track 1 IP SLA. There you go, guys. So here's how you set the track operation to the correct SLA. The SLA operation number was 1 that we create, and we are simply just testing reachability. We just want to make sure that we can reach that address. Within here, we're not going to mess with anything right now. We just kind of want to leave everything default. So now I guess you guys can already guess what we're going to do now. We're going to get back into that sub mailbox, that sub interface for VLAN 1, and we are going to type in standby and the group number. Track 1 was the track number, and we are going to use the option to decrement. And remember I said we need to decrement by 51. We're currently at 150, so in order to get lower than the default for R1, which is 100, we just go to 51. So that will take us to 99, and that would suffice. And after that, we're good. So guys, we've set up the SLA operation to send the ping to 3.3.3.3, and we are tracking that for reachability, and we've tied that tracking to the Hsrp standby group. So this guy is now part of the configuration, and if we ever lose reachability to 3.3.3.3, we should decrement by 51, leaving us at a priority of 99. R1 should be configured to preempt and take over as an active gateway, and we should resume forwarding even if there's a failure on that Ethernet 02 interface of switch 5, which is the upstream port that R2 is connected to. So let's go ahead and test this out. So we're going to go back over here to the switch. Oh, and it looks like that has timed out. So we're going to have to go back over here to the switch, open that back up. That is the wrong window. We're going to open up R2 as well. And we're going to get that ping window rolling again. So you see pings are going great right here. We're going to get into that interface. Let's go ahead and restart this too. So just to make sure, we are still going to router 2 to get there. So now we are going to ping 3.3.3.3. Looks like everything's working good. So let's go ahead and do it again. Only this time we'll set a higher count so that we can see the functionality of this failover. So we're going to shut the interface down for R2. The line protocols went down. We should see some timeouts because the traffic can't physically pass. R2 looks like its neighborships have gone down for Hsrp, and we shortly should see an Hsrp message telling us that R2 has demoted itself from active to standby and that R1 should be taken over. Let's go ahead and do a verification command. Okay, so it says that our IPSLA 1 reachability has went from up to down. We'll give Hsrp a little time to do something with that. And hopefully it should demote itself. And it is not demoting itself. We set up the tracking object. Aha. So it looks like we did not set up the track correctly. So let's go ahead and bring this back up and allow those packets to flow. This is actually just a really good example because we have a clean slate and we'll be able to show you guys the functionality when we apply it to the interface. So I'm not sure where, maybe we put it on the main interface to show run int E0. Nope. I am not sure where we put that, but I thought we put it in there. So either way, we are passing packets again, guys. So we are going to make sure that we do this correctly this next time. We're going to decrement it by 51 if that track operation goes negative. Okay, so we should be good here. Let's try this again. So we're going to shut this interface down. We'll start seeing the timeouts, the packets stop flowing. Now that we're on the right interface with the track operation, we should see Hsrp finally have that SLA go down. Looks like the neighbors are going down now, and it should decrement its priority and in turn allow R1 to assert itself as an active gateway. But you see we do have a lot of packets going down. So that took a long time. And as you can see, the SLA1 reachability has went up from up to down. That was a lot of packets, guys. And you see that where you have resumed connectivity. So just for a second, I just want to stop this ping. I want to show you guys how many pings we lost, how much traffic we lost. That is a lot of traffic. You see that's just the default. And now we can also do a verification and make sure this is going through 10 now, which it is. Cool, so that proves our point that Hsrp and enhanced object tracking actually did its thing. That wasn't too ideal though. I mean, I'm sure you guys can tell that was a lot of packets that were going missing. So one thing that we can do is we can get in there and we can change the thresholds and the timeouts in the actual track operation itself, in the SLA operation itself, to say whenever that SLA operation considers that reachability to be lost, you know, we need to take away from that time. Another thing that can happen is the actual Hsrp hello intervals between router 1 and router 2 can definitely impact how fast they're able to renegotiate an active gateway. A third thing that can certainly affect it is layer 2 convergence. Depending on the topology or what you have set up between R1 and R2 and the destination or your ISP or what have you, if there is a switch like there is in this circumstance, that layer 2 reconvergence from that link failure on Ethernet 02 in this case, that could definitely have an impact, and that could be something where if you don't have control over that switch, well, that's just some time that you're not going to be in control of, and you're not going to be able to make a deterministic convergence time there. So all of these things are sort of just tools that you have at your disposal to say, okay, I have it working. We resume connectivity automatically. That's awesome. But me as the engineer, I really want to figure out how I'm going to not lose that many packets. I want to make sure that my branch office or whatever, we're doing super critical work and we can't be down for that long. So let's take a look at how we can do that. So the first thing is that on R2, the first thing at our disposal is that if we go back into that tracking, and actually let's get everything back up to normal. So let's go to no shut on that port on the switch, and I keep hitting that wrong one, and let's make sure R2 comes back up. He's a standby still, but he should come back up and his priority should be reinstated to 150. See, it's configured for 150, but right now it's 99 still. So in the meantime, let's get back. Let's do no Ip Sla 1. Okay, so that gets rid of the total Ip Sla. So we'll have to remake it. So let's get back into Ip Sla 1, because this is only set up on R2. And we said that it was going to be an ICP echo to 3.3.3.3, and we're going to source it from interface E00. Enter. And then let's get into the frequency and the timeout and the threshold. So let's go ahead and set the threshold for, let's say the threshold is 600 milliseconds. Now let's set the timeout for 600 milliseconds as well. Let's set the frequency of the operation to a little bit less than the default. So let's set it to 1 second. We want to make sure this is happening very quick and that we have a very low threshold, so that as soon as we possibly can, this SLA operation will give us that return code of down for reachability, and we can pass that information to the Hsrp, and hopefully we can adjust the Hsrp timers to make that conversation go a little bit quicker. And that's sort of all we have at our disposal right now to make this happen quicker. But hopefully we can get rid of all those timeouts and we can make things a little bit more efficient. So set the frequency to 1, and we are done configuring the Ip Sla operation. So let's go ahead and schedule it. Start time now, life forever. Enter. Let's go ahead and verify that that has created. Return code is okay. And we are back to active. We've been promoted back to active, so that's awesome. We need to track 1, Ip Sla 1, and reachability. We need to redo that command because we got rid of it when we got rid of the SLA. And now let's go into Ethernet 01.1, and we're going to mess with some of the timers. Now we want to change the timers on both sides, but since this operation has only been configured on R2, that's the only side that we had to do any adjustments to the SLA stuff, because this is the only side that's getting demoted and then reinstated depending on a link failure. So over here, everything's still going to start with that standby 12. Then we're going to do a space, and you can see there's nice little keyword timers. Now you can do the hello interval in seconds or the intervals in seconds, but if you really want to get that sub-second failover that we're trying to achieve, you're going to want to use the msec keyword, which is milliseconds. And let's go ahead and do the hello timer every 100 milliseconds And let's go ahead and do the hold time in, let's say 500 seconds. 500 milliseconds, I'm sorry. So now that we got that going, let's hurry up and go over to R1 and do the same thing. And we are going to standby 12 timers. We're going to use that msec keyword again, and we are going to set it up exactly like we did on R2. Okay, so let's do a verifying command and just make sure everything is configured, because I know I've been messing up on you guys. So we just want to make sure that this standby 12 timers command is on R1 and that it is also still on R2. And it is. Still set for preemption. We still have the track 1 decrement 51. Everything should be good, guys. We changed the SLA operation to change the threshold and the timeout and the frequency of the SLA operation, so that should help us out. We've also changed the Hsrp timer so that that conversation happens a little quickly when it's past that link detection notification from the tracking object. So we should be good to go. Now the only thing left for us to do is to put this bad boy into action. So let's pull back up switch 5, let's pull back up to VPC, and let's see if we've made an impact for the packet loss that we're going to experience during a failover. So we have switch 5 here, and where's our VPC? Boop. And don't tell me we need another VPC. Every time I do this, it actually takes away all my tabs. So it's great. I don't know where my VPC is. Okay, guys, the quickest way for me to do this is to go ahead and stop that and start it again, because I cannot find it, and you guys do not have time for that, and neither do I. So now that we've started it, we should set it to DHCP and it should get an address, so that will be good. So it looks like it's got the IP.200 once again. Let's just go ahead and verify that we have connectivity to our gateway. And we do. Okay, let's make sure we have connectivity again to that 3.3, and we do. And let's make sure that we are going towards our R2, which has the higher priority of 150 currently, and we are. Okay, guys, so let's get back on track and let's start pinging our destination with a count of something absurd so that we can actually see something happen. And let's pull up switch 5 and let's pull up R2. Alright, guys, so we'll get back into and now the switch 5 has died on us and timed out. It hasn't died, but it did time out, so we'll have to open everything up again. Stay with me, guys. So R2, this is all a part of labbing. This happens to me every night. VPC. Okay, cool. So we are going to start the ping. Boom. We verified it's going through R2. Everything's gravy. We are going into the southbound interface, and we have everything set up over here. We've adjusted our timers. Let's see what happens. We're shutting down. Oh, we only lost 2 packets that time. That is so cool. So this is a really cool lab for you guys to do at home. But it was super cool to be able to see all of the packet loss that happened, which is virtually just infinite amount of packet loss if you haven't set up a tracking object for that ISP connection, right? It just kept going and going and going, and you were losing packets because it was never switching over, because Hsrp isn't built to by default have a mechanism like that to be intelligent upon why you're using it. It's just like, hey, I'm the active gateway. So without that enhanced object tracking, you're really dead in the water, and it's sort of pointless for you to even configure it in the first place. So we set up the basic tracking object with SLA operation, but as you guys could see, just the basic stuff is not enough. You're still missing tons of packets, and who knows who's going to come yelling at you and say, hey, I thought you had Hsrp configured, what's going on? You're going to be like, I do, but if you guys really start to drill down, just really understand the tool set that's available to you guys as engineers to go in and to change things, play around, go on Cisco's documentation. They have tons of information on their recommendation, their best practice for timers, etc., etc. This is just something I did for the lab, and I was just in here messing around with different timers and stuff like that to get an idea of how I could impact it. And as you guys can see, it was a pretty big impact. I'd say going from about 20 packets to 2 timeouts and then resuming is pretty cool. And if you guys don't believe me, we can go ahead and do a chase again and verify that we're going through .10 like you can see down there. Pretty cool stuff. So guys, I just want to thank you so much for watching this video. It's been a pleasure, and I had a good time, and I just want to thank you guys for bearing with me, and I'll see you next time.